In this lesson, what we're going to be talking about is acceleration as well as free fall. Basically, anytime acceleration is happening, we get the velocity of an object that is changing. Now, this is very important that we're talking about velocity and not speed. So, acceleration, because we're talking about velocity changing, we can have acceleration occurring when something changes speed, or if its speed is constant and it changes direction, like for instance circular motion, or if it changes both of those things. But for the most part, we tend to think of acceleration as an increase of speed. But it can be really any change in the velocity. It's not always an increase, it can also be a decrease. If the speed of the object is increasing, we refer to that as being a positive acceleration. And if the speed of the object is decreasing, we say it has a negative acceleration. But with a negative acceleration, we often refer to this as a deceleration process. Now, just like speed, we can actually graph acceleration. But what we have to do is we use a different type of graph. It is a speed versus time graph. So instead of distance versus time, we have speed versus time. So on the speed-time graph, and like I said before, it has to be speed versus time instead of distance over time. The positive acceleration will be shown this way. The slope of the line will be up and to the right. Now, negative acceleration, we get a downward slope and also to the right, because remember, time is passing. So this would be a deceleration. Now, if you look at this one, we also have this horizontal line here. What does that horizontal line mean? It means that we have a constant speed, because remember, it's not no movement this time because we do have a speed. So the speed here is staying the same, but we're not accelerating. So if I see a horizontal line on a speed versus time graph, it is a constant speed. So again, anytime an object changes direction, its velocity is going to change, and therefore it will be accelerating, like a car on an oval track, like in an event like a NASCAR event. Now, we can also talk about constant acceleration, and this is where the velocity changes by the same amount each second. And this is a straight line on a graph. So the two lines that we saw on those speed-time graphs are actually constant acceleration or deceleration because they have straight lines. However, we don't always have straight lines. And if it's nonlinear, in other words, it's not a line, it's a curve, that means that we have unequal acceleration. And so we would get a line that looks like this instead when we have unequal acceleration. We're still accelerating, it's just not an even acceleration all of the time. Now, just like we had instantaneous speed, we can also have instantaneous acceleration. This is basically how fast we are changing at a very specific time. And again, it can be change in speed, change in direction, or both. Now, we can run through calculations regarding acceleration. And the formula for acceleration is this: A equals VF minus VI divided by T, where A is the acceleration, F is your final or ending velocity, VI is the initial or the starting velocity, and T is the time. When we calculate acceleration, we do end up with a unit. We have a distance unit divided by 2 time units, and those 2 time units do not have to be the same. For example, we can actually have them the same. For instance, with the first one, meters per second squared. So the velocity is in meters per second, and the change in time is measured in seconds. But we can also have them be different. For example, kilometers per hour per second. So in other words, the velocity is being measured in kilometers per hour, and we are seeing how it changes every second. We can also measure how far something travels because of the acceleration. So we can calculate the distance something has traveled during acceleration by using d equals 1/2 at squared, whereas a is the acceleration and t is the time that has elapsed. So let's take a look at a practice problem here. So we have a ball that is rolling down a ramp and it's starting from rest. After 2 seconds, its velocity is 6 meters per second, and we're trying to find the acceleration of the ball. So if we remember our formula, we have A equals VF minus VI divided by T. And sometimes it's helpful to list these things out. So we're looking for the acceleration. That's what we don't know. The final velocity is 6 meters per second. Now its starting velocity. There's not another number given, but it says it's starting from rest. So when we're starting from rest, it is not moving, so that is 0 meters per second. And the time is 2 seconds. So we plug that into our formula. So A equals 6 minus 0 divided by 2. And when I do that calculation, I get 3, and that's got the correct number of sig figs there. Now, I have meters per second divided by seconds. So I could write it like this, meters per second divided by seconds, or that could end up being meters per second squared. Let's take a look at another practice problem. So now this time we have a car. Car is traveling at 10 meters per second and it starts to decelerate steadily. It comes to a complete stop in 20 seconds. What is acceleration? So let's list things out here. We're looking for acceleration. Its final speed. Now it's starting off traveling at 10 meters per second, so that's actually its initial. If we read the problem though, it comes to a complete stop. So when you stopped, you're not moving. So we have a speed of 0 meters per second, and the time is 20 seconds. So again, let's plug that in. A equals 0 minus 10 divided by 20. Now when I do this up on top here, I'm actually going to get a negative number, and that's fine. Remember, we can have negative accelerations because in this case it is decelerating, and that's just perfectly fine. When I do this division, I get a negative 0.5 on my calculator, and that actually does have the correct number of sig figs. And with my unit, it is again the meters per second squared. Okay, an airplane travels down a runway for 4 seconds with an acceleration of 9 meters per second squared. What is its change in velocity during this time? So we have A is 9 meters per second squared. Now when it's talking about change in velocity, it's looking for the quantity VF minus VI. And the T is 4 seconds. So we take 9.0, and that is equal to VF minus VI divided by the 4. Now you need to be careful here. You need to multiply both sides by 4, and so we get 36 meters per second is equal to the VF minus VI, and that is our final answer. Now a couple of other notes with acceleration. We can have a special type of acceleration which is called free fall. Free fall is the movement of an object towards Earth due to gravity. Now with free fall, we are assuming that no air resistance or friction are present. Now the nice thing about free fall is we actually already know the acceleration. It is at a rate of 9.8 meters per second squared. So what this means is for every second an object falls, it's going to gain 9.8 meters per second of speed. Now for most free fall objects, because I'm dropping them from a height, my initial velocity is 0. And the nice thing about this is because free fall is created by gravity, it is the same, the acceleration rate is the same for all of our objects. But we do have to be careful. Free fall on Earth really doesn't exist because we do have things like air resistance, but we tend to ignore things like that, especially when we're introducing this topic here in high school. Now, based on free fall, we can actually calculate the speed of something during free fall, because the velocity of a free-falling object equals the acceleration times the time. In other words, v equals a times the t. And we already know what that a is, so all we really need to know is how long it's been falling, and we can figure out its speed. Now, free fall applies to both things that are dropped from a height as well as things that are tossed up in the air. So if we think of something that's been tossed up in the air, gravity is always pulling it down. So as it is moving up, its velocity is going to decrease by 9.8 meters per second, and then when it reaches its highest point, its speed is actually equal to 0. So if I throw something up in the air with a speed of 30 meters per second, 1 second later, it's going to be down to about 20 meters per second, then 10, and then at the very top is 0. Now, on the return, it's actually going to act very much like a free fall object. It's going to gain speed at a rate of 9.8 meters per second squared. So it's going to start at 0. After 1 second, it'll be at 10, and then at 20, and then finally at 30. Now, objects in free fall gain speed until they reach something called terminal velocity. This is the constant speed that an object reaches due to its air resistance. And for an average person, that's about 200 kilometers per hour. Okay, so let's take a look at a couple of free fall problems here quickly. So the first one here, we have a child dropping a ball from a bridge. Ball strikes the water under the bridge 2 seconds later. What is the velocity of the ball when it strikes the water? We are going to use the exact same acceleration equation as we used before. This time we know its acceleration is 9.8 meters per second squared, and this is positive because it's falling down. Its final velocity is what we're looking for. Its initial velocity, because it's getting dropped, is 0. The time that has elapsed is 2 seconds. So let's see how we set this up. 9.8 equals VF minus 0 divided by 2. So I end up with 9.8 equals VF divided by 2. I multiply both sides by 2.0, and what I get is 19.6 meters per second equals VF. Now, it needs to be with correct sig figs, so I need to round that to 2. So I would have 20 with the decimal point meters per second as my final answer. And let's do one more. All right, in the second one, we have a boy throwing a rock, and it's going straight up into the air. It reaches its highest point after 2.5 seconds. How fast was the rock going when it left the boy's hand? Now in this case, we can do the exact same thing. We have our acceleration, our VF, our VI, and the T. Now in this case, our acceleration is actually negative at a negative 9.8 meters per second squared. Our final velocity, it's reaching its highest point, and remember at the highest point, the speed is 0. We're looking for the initial speed, and the time is 2.5 seconds. So, if we go ahead and we set up the equation, we get a negative 9.8 equals our VF minus VI divided by 2.5. So I get negative 9.8 equals negative VI divided by 2.5. Okay, so then I take 9.8 times 2.5, and I get a negative 24.5 is equal to my negative VI. Multiply both sides by negative 1, and those turn into both positives. Now I do need to look again at sig figs, and so I have 2 sig figs and 2 sig figs, so my answer will have 2. So my final answer is a 25.0 meters per second equals VI. Remember, you can't have a negative speed, but you can have a negative acceleration. So for your homework in this part, you have a sheet of acceleration homework problems that you should work on. And then next we will actually start talking about forces.